this has CM type corresponding to some CM. The endomorphism ring of this guy is the full ring of integers. Okay? The basic case that one looks at. Then the conjecture is that if you look at the Galois orbit of this point x, let me write it as the degree of the field definition of x over q grows at least as fast as some constant times the discriminant of k to the power of some positive number that depends only on g. Okay? So, some quantified version of saying that Galois orbits are large. In fact, you can state sort of an easier conjecture, or theoretically an easier conjecture, where you just sort of say finitely many of these are defined over Q, for example, or something like this. And in all the approaches I know, somehow, they're the same difficulty. So if you can prove anything at all, you'll probably prove something like this. At least that's what experience somehow shows. And so then it's a theorem, sort of as a result of a lot of work in the past sort of 5 years, or maybe 4 years. So it's due to Pila and myself in the case of AG, and then Klingler, Ulmo, and Yafaev, together with some recent work of Christopher Daw and Martin Orr, for a general Shimura variety. And what this theorem says, I only state it in the case of AG again, because I didn't state this conjecture in general. But if you assume conjecture 1R for R less than or equal to G, then you get Andre Oort for AG. And if you assume somehow the corresponding conjecture for general Shimura varieties, then you get Andre Oort for a general Shimura variety. All right? So somehow I'm not going to say any more about Andre Oort. From now on, I'll be focused entirely on this somehow, independent conjecture. So what was known sort of so far, the most sort of general version, there's been some also similar work by Ulmo and Yafaev, and then I proved in my thesis that so conjecture 1G is true for G at most 6. Somehow there's some trickery you can play, and then it just stops working after a while. So today I want to announce sort of recent work with a little t, because it's still based on some work in progress, that 1G is true for all G. So as a result, you get Andre Oort for AG. So let me sort of mention that it's sort of natural, given this, to try and do the same thing for a general Shimura variety. But it seems very unclear how to generalize the approach to a general Shimura variety. So maybe it's possible, but the experts I've talked to seem to have sort of a lot of skepticism. So before I move on and just somehow talk about this problem and explain what it's really about, let me just give you a brief sketch, a very informal sketch of why this conjecture could possibly be useful to prove something like Andre Oort, why you might care. So just like a 2-minute thing. So suppose that you have a subvariety V, say in AG, which is a, for which Andre Oort fails.
車内清掃終了の放送がございますまでしばらくホームでお待ちください。すぐにはご乗車できませんのでご注意ください。6両の運転となっております。改札を入りましたところ、左手先頭号車、緑のマークのうち4番から左側、階段奥、屋根のあるところまで6両の運転となっております。
ホームと列車の間に隙間がありますので、足元にお気をつけください。すみません。 まもなく
ちょっと降りないんですけど、コーヒーだけ買っていいですか？
ご注意ください。ご乗車の際はホームと列車の間に隙間がありますので足元に。
終電の皆様です。
あ、どうも。
ご協力ありがとうございました。ご乗車になりましたらお待ちください。1番線に停車中の列車は18時44分発、普通列車の高崎行きです。沼田、渋川、新米橋、東京方面、普通列車高崎行きです。
have something called the Shimura reciprocity map. And what it does is the following. You let K star be the reflex field associated to K together with its CM type. So it actually depends on this as well, but it's somewhat